Okay, so just now I have discussed the concept of Clausius Clapeyron equation and how you apply it to any system of importance. Now let's see some example from Gates papers. What kind of questions are being asked? So let's get started with that. Okay, so this is the question being asked at 2005 GET Metallurgy. And this is the question from phase equilibrium in one component system, and the Clausius Clapeyron equation is involved here. Now I'm reading out this question. You can also find it if you have a book containing previous year's question papers of GET. You can also find this question at GET 2005. This question was asked. This is I guess the question number 81A and 81B. Anyway, it says that the vapor pressure of solid M varies with temperature T in Kelvin as ln P. The expression is given in terms of temperature, and the vapor pressure of M varies with temperature T in Kelvin as ln P minus 3320.85. Now, what is being asked? The temperature of the triple point of M in Kelvin and the heat of transformation of M for liquid to vapor state transformation. See, the first expression, gives the, combination of pressure and temperature for equilibrium between, solid and the vapor pressure of a solid. There's the solid vapor pressure. And the second expression gives the equilibrium between the liquid and the vapor state. Okay. So there are three, states involved here. There's a liquid, there's a solid, and there is a vapor phase. So please note it down. You can pause the video as I always say, and I will just proceed with solving this problem. Fine. Let's see how we solve this problem. Right? So it says there are three states, right? So I'll draw two lines. So one line is the metal M liquid and M vapor. Okay. So one line is metal as solid. Okay. I will just do it a different way. So let's say okay. This is one state. Let's say this one. Let's do it. Just please understand this concept. Okay, it's very important. The free energy G let's say this is liquid, and let's say this is solid. This line actually doesn't exist, so I will just sorry. This line actually doesn't exist, and this doesn't exist. Let's say this is liquid and this is vapor. Okay, be vapor imaginary, and this is liquid imaginary. Let's understand now what I have drawn. The dashed line is not clear, right? Let's redo this line. Now the dashed line is clear. It's just the continuation of the line. I'll just drew it. Sorry for these interruptions. Okay, and I will just break this line into dots. It's a plot between temperature. This is vapor, and let's say this is liquid. Okay, it's not steam, always remember. Okay, this is a continuous line. This is liquid. So liquid and vapor equilibrium is there at a particular temperature. There's a at a particular the pressure variation, or let's say it can be at a particular pressure also. You can the pressure can also be a variable here. So this is the free energy versus this line. Okay, this is how it varies. So why I've drawn this line? Please understand. This is imaginary line because vapor won't exist beyond this point. Okay, because the free energy for the liquid is lower than the vapor. Okay, so had it existed in vapor, this would have been the line. And for this liquid, it doesn't exist beyond this point because the vapor pressure for vapor, the free energy is lower. So this is an imaginary line. Similarly, for a solid, the solid line might look as this. I'll just break it. Let's say it's solid. Okay. So solid line, this is one. So if I remove this point, this dashed lines, what we are left up with? We are left up with three lines. Right? So liquid, solid and vapor. Or ideally it would be liquid here. It will be solid. Doesn't matter. And this is vapor. It's not visible. Right. Liquid, solid, vapor. So these all have its own imaginary lines if you just extended it. If we just extended it, and then we just extended it. Okay. So this had been the liquidus line. Had it existed in liquid, it won't be like that. It will be something